Hello, we're Team 12B of the WPI VIBE summer program, working on a portable centrifuge for anemia diagnosis. This is our team of biomedical engineering students from a variety of universities around North America. Anemia is a severe global public health problem that affects young children, menstruating adolescent girls and women, and pregnant and postpartum women. Patients with anemia have a reduced number of red blood cells. When left untreated, symptoms can include crippling tiredness, heart failure due to excess stress on the heart, and even death. Currently, hematocrit testing through centrifugation is one of the ways to diagnose anemia. However, centrifuges require electricity to generate power. Therefore, current centrifuges are not reliable in those low-resource areas. Therefore, our group is working to create a portable, low-cost centrifuge that does not rely on electricity for anemia diagnosis in low-resourced countries. Next, I'll pass it on to Sophia to talk about our proposed solution.
So for our proposed solution, we have multiple tactical barriers and measurable goals that are to be discussed. For instance, in our technical barriers, we have to decide the appropriate threshold point, which means that our threshold point would have to be around 4,000 RPM for blood separation to be adequate. In addition, we have to make sure we understand the type of blood collection tubes, such as glass or plastic, as plastic can have a greater chance of coagulation for the blood. In addition, appropriate power sources are to be considered. Some measurable goals are listed, such as accurately diagnosing anemia based on the blood count from the separation, and having 90% or above selectivity. So this means that the RPM reaches at least 4,000 each time the centrifuge is activated. In current modalities, centrifuges that are shown in the market require constant electricity and can be relatively expensive, around $300 to $400. In addition, they require constant electricity and they are found to be bulky, around 4 pounds, and are not easily portable. The limits of their ability to reach in low-income countries that can be diagnosed and treated properly with this type of medical device. Now I will pass it to Bayan, who will be talking about project scope.
The scope of this design project is to provide a portable centrifuge medical device that can be utilized in developing countries with minimum electricity and accessible materials by reaching at least 4,000 RPM for blood separation to diagnose anemia. I will pass it to Ali to talk about MVP and estimated cost.
Our design is a hand crank centrifuge that can spin at high speed without electricity. The main components are a handle to power the device by hand, a gearbox to increase rotation speed, and a top panel to hold 2 vials of blood samples. The user will rotate the handle at about 50 revolutions per minute for 10 to 25 minutes. The device uses 5 gears with a gear ratio of 81 to 1, which will cause the final gear to rotate at 4,000 revs per minute, which is suitable for separating blood and is similar to many current electric centrifuges. The device is made out of ABS plastic, which is a thermoplastic known for being durable, chemical and heat resistant, and lightweight. ABS plastic costs 86 cents per cubic inch, and it can be used in most 3D printers, making it very accessible. By estimating the volume of each component of the centrifuge, we calculated the total cost to be around $43.20. Thanks for watching.